Hello everybody, my name is Lyndon Kwan and today I'm going to tell you about seasons and adaptations of plants and animals. And this video is also from the Learner's Book Cambridge 5 Science Learner's Book. Okay, so this is the contents of the template. Unit 1. Why does the Earth move around the Sun? Lesson 2. Seasonal changes. Unit 3. Adaptations of plants and animals to an environment, and Unit 4, adaptations of predators and prey. First, we'll talk about the first unit. The Earth moves around the Sun. This is the Earth's orbit. The orbit is an ellipse shape. That is not a perfect eclipse, so scientists call it a slight eclipse. Because the shape being a slight eclipse, the Earth is sometimes further away or sometimes closer to the Sun. The average distance of the Earth from the Sun is 150 million kilometers away from the Sun. The Sun makes a stronger gravitational force than the Earth does, so that keeps the Earth orbiting around the Sun. Seasons. There are 4 seasons as we know: spring, summer, autumn, and winter. Seasons are caused by the orbit of the Earth and the tilt of the Earth's axis. The seasons that you have determined by the hemisphere you live in, countries between the north and the equator or the northern hemisphere, and the countries between the south and the equator or the southern hemisphere. There are different seasons in different parts of the world. Notice, the side of Earth is facing sun is day, and the opposite side that is facing, like the opposite side, is always night. So the tilted axis causes the southern hemisphere to be tilted towards the sun, and a few regions inside the South Pole is having continuous daylight. Unit 2, seasonal changes. Adaptation of plants. Plants' leaves are green because they contain a substance called chlorophyll. And if you don't know what chlorophyll is, it's like a part inside the cell. The chlorophyll in the leaves helps produce food for the plant, also known as photosynthesis. And the way it does it, the plant uses stored energy to convert carbon dioxide absorbed from the air and water into glucose, a type of sugar that then the plant uses to have energy. During autumn, the days become shorter and there's less light, and the leaves are unable to make food of the tree. So the chlorophyll breaks down and the leaves start to change color from green to yellow, yellow to red, and finally the leaves turn into brown and all of the leaves fall down. And when the temperature gets warmer, the tree grows back all of its leaves. Adaptations of animals. Hibernation. Hibernation is a state when an animal's body goes into a dormant state, and dormant means like going to sleep for a long period of time. During hibernation, the animal's heart rate and breathing slow down, and its body temperature drops. Migration. When the season change and there's not enough food for the animal to eat, some animals migrate to warmer regions where there's food. Animals that eat grass need a constant supply of all of it year around. But in many parts of the world, the grass dries up, so they have to move to a new place where there's new grass to eat. This is called migration. In late summer, the days get shorter, so many birds begin their migration. They eat more food so that they can have strength to survive a long journey, and then they fly long distances to places where there is food for them. Unit 3, adaptations of plants and animals. Adaptations of plants and animals in hot, dry places. Plants. Here are some adaptations of plants in hot and dry environments. Some of them have small leaves or either no leaves at all. These This reduces the surface area of the plant, which helps minimize water loss. Spines deter herbivores from eating the plant, which helps to conserve water. And deter just means like stop it from hurting or eating it. Shallow root systems. These root systems absorb water quickly through the influent waterfalls. Thick waxy coatings. These coatings help prevent water loss from the plant. And here's some adaptations of the animals. Okay, so the first one is being nocturnal. This allows animals to avoid the hottest part of the day, which is the morning. And when the morning falls down, nocturnal animals will come out because it's less hot, and there are other animals that are going to sleep. And after that is storing water in their bodies. Camels, for example, can store water inside their humps, which later he can use for energy. Pale colored fur or skin. This can help reflect sunlight and keep the animal cool. Adaptations in wet environments. These are adaptations of most aquatic plants. Large, flat leaves that float on the water. These leaves help the plant absorb sunlight at the water surface. Big air spaces in the leaves and stems. These air spaces help the plant to float. Small roots. Because these plants in the water all the time, so it doesn't need large roots to anchor itself to the soil. There are many animals inside wet environments, but I'm only going to tell you adaptations of common animals. First is fish. Fish use gills to absorb oxygen from the water and fins to move quickly through the water. Ducks and geese. These ducks and geese use webbed feet to help them swim. Seabirds, they have waterproof feathers to keep them dry and special glands to get rid of excess salt which harms your body. Flamingos, long, thin legs to walk through water easily and long. Flexible necks to reach food below the water surface. Adaptations of animals and plants in cold environments. There are very cold environments in the far north and far south of the world. These regions have long summer days and very long dark winters. There is not much rain, but there's a lot of snow in the winter. The soil in cold regions freezes in summer only. The top few centimeters tall. Trees and other plants have adaptations in these conditions. Some animals have thick fur to keep them warm, but during the winter there's no food, so some animals might hibernate or migrate, and we already know what hibernate and migrate means. And the last lesson, adaptations of predators and prey. Predators, cheetahs are incredibly great hunters. Let's see some adaptation that it has to be such a great predator, and this is the example for a predator. Okay, first is their speed. Cheetahs are the fastest land animal on Earth. They can run at speeds up to 70 miles per hour, 112 kilometers per hour. This speed allows them to catch their prey that would otherwise be able to outrun them. Next is the extreme body shape. The cheetahs have long, lean bodies with a small head and thin legs. This shape helps them reduce air resistance while they run. Eyes. Cheetahs have forward-facing eyes, which gives them a good depth precision. This is important for judging the distance of their prey. Camouflage. Cheetahs have fur that has tan with black spots. This coloration helps them to camouflage in with all those tall grasses where they often hunt in the savannas. This is just only one predator, but there are many others with different adaptations like venom, sharp claws, or trapping other prey. Prey adaptations. These are the adaptations of other animals called a springbok, the prey of the cheetah. Speed. Springboks are fast runners. They can reach speeds up to 55 miles per hour 89 kilometers per hour, which is still lower than the cheetahs. However, they cannot maintain these speeds up to long distance, so as cheetahs can run. Zigzag running. When springboks are chased by a predator, they'll often run in a zigzag pattern, which makes it more difficult for the predator to catch them. Herding. Springboks live in large herds, so this provides them to one in safety numbers. If a predator attacks one springbok, the other springbok will run away, making it difficult for predators to catch any of them. Starting. When springboks sense danger, they will sometimes perform a stunning behavior. This involves standing on their hind legs and leaping into the air. Although that starting may startle predators or signal other springboks that there's predator, but that's only one animal. That's always a reminder. That's only one animal, and there are many other adaptations that other prey use, such as quills, poison, and other adaptations. And here are some other prey adaptations. This is defending. Most animals tend to use adaptations to defend themselves, like mimicry. Mimicry is like looking like another animal or something else. So like if you see a lizard and it kind of looks like a snake or something, then yeah, that's mimicry. Camouflage. The animal changes color or uses skin patterns to blend into the environment, and so predators cannot see it. Hiding in groups. Hiding in groups is a good strategy because if a predator tries to attack them, the rest will run away, running away from the area. And speed is also good because when a very slow predator is trying to catch you, then the speed is very good because you can run away and the predator cannot catch up to you. And predators also have attacks. They also have attacks like quills. Quills are like spikes when they can poke into you and you hurt a lot. And poisons that harm the predator, and chemicals which makes the chemical irritated and they run away. And stings and bites, which also irritates them and in some cases could kill the predator. Thanks. Bye bye. Thanks for listening.